Hello guys, welcome back to ptet.chemistry channel. So in this tutorial video, I'll go through this year 9 level kind of chemistry. This is about balancing chemical equations. So typically students who have learned about formulas, chemical formulas, some very general and basic chemical formulas, like this is for the element copper, this is oxygen. Oxygen does not exist as a single atom. Instead, what they do is they form covalent bond to each other, they form double covalent bond, they form two covalent bond with themselves. This is still element because both of them are the same type of atoms. So there's O2. Then you have nitrogen, which is nitrogen triple bond because group 5 element, 5 outer shell electrons share 1, 2, 3. 5 plus 3 give you 8 electrons around the outer shell for both atoms. That's why O2 and N2 is how they exist as at room temperature and pressure. Now you have hydrogen, which will exist as H2. Both of them get a fully filled outer shell, which is that of the noble gas, helium, because they're in the first shell, 2 electrons, they are sufficient to fill the outer shell completely. And then you have the what we call the halogen. Halogen are the group 7 diatomic molecule. And again, group 7, so 7 plus 1, they like to share 1 electron, so this would be Cl, Cl, it could be Br, Br, it could be II or FF, they're all diatomic molecules like that. So these are all simple formulas that you're supposed to have known prior to balancing chemical equations, something you have learned from structure and bonding, from which you can check, you can check my other topical playlists, where there are lesson tutorials on the on the structure and bonding stuff. Okay, so here this is copper 2 oxide as stated in the previous tutorials on the other work, where we try to get formula from name. Now from the formula we have to try and name it. You know it's got O2 minus, and therefore you only have one of the copper, so that means it must be copper 2 plus, because the charge 1 of the copper 2 plus is 1 time plus 2. It will balance out 1 time minus 2, so one of these and one of these give you 1:1. Copper 2 oxide, that is the name. All right. I mean, this exercise is less so about the name itself, but it's important to be able to name this. This is a potassium oxide, so this is K plus O2 minus, so you need 2 of it there. You gotta be able to write formula before you even try to balance them in the first place. All right. This is sodium hydroxide, Na plus or OH minus, so Na plus OH minus, so there is sodium hydroxide there, NaOH. This Fe3O4 is actually a mixture. Okay, Fe3O4 is a tricky one because Fe3O4 is not O3 minus, it's actually FeO and Fe2O3. So you can imagine this one as being Fe2 plus O2 minus, this one as Fe3 plus, 2 of them, and then 3 of the O2 minus. So what happened then is when you add them up together, you will get 3 Fe, and 1 oxygen plus 3 oxygen give you 4 oxygen. So it's a mixture. It's a mixture of the FeO and the Fe2O3 in a 1:1 ratio. Okay, so it's quite common for students not knowing what this one is. All right. Mg and HCl, this is magnesium chloride. Mg is group 2, Mg2 plus Cl minus, so it's MgCl2. Each of these is a hydrogen gas, and that exists as H2 diatomic molecule. This is carbon dioxide. Carbon dioxide, you would have learned it under structure and bonding as well. So carbon form 4 covalent bond. The carbon will have 8 electrons in the outer shell. Each of the oxygen has 6 electrons in the outer shell. They share 2 more, they get 8 electrons in the outer shell. SO2, this is called sulfur dioxide. This is called carbon dioxide. This is Pb2 plus and O2 minus. The only reason I know it's Pb2 plus is because there's only 1:1. So I have 1 of the O2 minus, and therefore I have 1 of the Pb2 plus. So this is called lead-2 oxide. This is zinc nitrate. NO3 minus is nitrate, and you have zinc, of which the formula is Zn2 plus. So that's why you need 2 of the nitrate in order to balance the charges for the compound. Okay. On the other side, you have NO3 minus, so it's Ag plus, which is silver 1 nitrate. This is lead 2 sulfite, is a SUl. FIDE. If you are from if you try a, well, actually there's another spelling which is SULPHIDE. If you like that, you should stick with it for all your spellings, but you gotta know the PHIDE is the same as the FIDE idea. So it's Pb2 plus S2 minus. It's called lead-2 sulfide. It's not just lead sulfide, because lead can be lead-2 or lead-4. Here is Pb2 plus S2 minus. Again, this is copper 2 oxide. Now this exercise is about balancing equation. I've just recapped a little bit about formulas, because it's important to think about formulas, to get the correct formulas before you actually try to balance chemical equation. Okay, let's get started with balancing chemical equation. They did say include appropriate stat symbols. I leave that, or maybe I'll add them in. Now I'll leave that another time. Okay, so here they actually put in the solid, but we'll learn more about stat symbols in the next topic. All right, but oxygen is obviously gas and gas. Maybe I'll put them in. So yeah, breathing in oxygen. At the moment, hydrogen are all gases at room temperature and pressure. Hydrogen is a gas. Carbon dioxide is what you're breathing out right now, it's a gas. Sulfur dioxide is a gas. Metals are solid. So S, potassium is a metal, sodium is a metal, iron, magnesium, zinc, that's all metal. Copper 2 oxide, Cu2 plus O2 minus, giant ionic structure, so definitely solid. Lead-2 sulfide, Pb2 plus S2 minus, definitely solid. Zinc is a metal, it's a solid. Silver nitrate, Ag plus NO3 minus, giant ionic structure. O2 is a gas. Carbon, whether it's diamond or graphite, is definitely a solid. H2SO4 here is an aqueous solution because it's a sulfuric acid. Acid is a solution because you dissolve it in water. The Mg does not react with the HCl gas. This is HCl dissolved in water. This is called hydrochloric acid, and therefore it's aqueous because it's a mixture. Now MgCl2 is going to be aqueous. Zinc sulfate is aqueous as well. Copper is a metal. Lead-2 oxide, giant ionic structure. Zinc nitrate is aqueous also. And sodium hydroxide is aqueous. You will use a lot of these in your qualitative analysis for your practical. Silver as a metal is a solid. Now to the balancing equation. So we have one copper, one oxygen, yet here we have two oxygen. So what we do is we need to have two of these in order to fulfill the two oxygen. Therefore it's one of the O2. We cannot change the formula. We can never change the formula, but we can put number in front because now there are two oxygens. So there's one oxygen giving us two oxygen. Now there are two copper. Okay, so that means CuO and then another CuO. So there are two copper altogether. Therefore I need two here. Okay, let me try and change the color. So now I have O2, and here I have one oxygen only because this two refers to potassium. You read from left to right, two of the potassium, one of the oxygen. Here I have two oxygen, so if I have one here, then I'll have two there because one of the molecule is two of the oxygen atoms. Having said that, now the potassium is, I have two of these, so K2O and K2O, so altogether there are four potassium, so there's four potassium there. Next one, sodium plus water. So here I have two hydrogens, so if I have one of these, it will not balance it because here if I put one, there will be two. If I put one, then there will be 2 plus 1, which is 3. So it cannot be 1 there because it will not be able to be balanced. So if I put 2 here, then I get 4 hydrogen and 2 oxygen. There's no oxygen, but there's an oxygen here to get 2 oxygen because H2O and another H2O because there are 2 of them. I need 2 oxygen there. And I put 2 NaOH here. I have 2 sodium, so I need 2 sodium. And how about this H2? Altogether, I have 2 water molecules, so it's H2O and H2O. I have 4 hydrogen, because 2 times 2 hydrogen is 4 hydrogen. I have 2 hydrogen here, so I need another 2 more, but this is a molecule, so I just need 1 of the H2 molecule. So 1 times 2 is 2, 2 times 1 for the hydrogen, so 2 hydrogen plus 2 hydrogen give me 4 hydrogen altogether, balancing the left and the right. Very, very important, yeah? Now the next one, this looks a bit complicated, but if I start by putting 1 here, so your decision really matters, which one you put first, yeah? Okay, this comes with experience, all right? So you got to practice until you're good at this. So this is 3 iron, so I need 3 iron. You might not get it right the first time. You might have to cancel something out later on, but at least you're trying. There are 4 oxygen and there's no oxygen. So if I put 4 here, now I have 8 hydrogen. I don't have any hydrogen. I need 8 hydrogen, but this is H2, so I just have 4 H2. How about Mg and HCl? So Mg2 plus Cl minus, so it's MgCl2. And then there's 2 chlorine. So if I have 1 here, then I need 2 chlorine, so I need 2 HCl. And there'll be 1 Mg, because there's only 1 Mg there. And now there's 2 hydrogen, so there's just 1 there. Now zinc sulfate, the sulfate, you can treat the whole SO4 as one whole unit. So there's one whole SO4, should balance out how many SO4 you have. If I have 1 zinc plus 1 H2SO4, then the zinc balance out. I also have 1 sulfate, and I have 1 of the H2, so just 1 there. Okay. Next one, so the copper oxide plus the carbon give me copper and carbon dioxide. It cannot be 1 1 1 1 because 1 oxygen, but here 2 oxygen, so I need to be careful here. If I put 2 here, then what will happen? If I put 2 there, then I have 2 oxygen and 2 oxygen there, but then again I only have 1 carbon, but I have 1 carbon. Oh, I think that's all right. So I had 2 oxygen, then I get 2 oxygen, and I have 1 carbon, and I have 1 carbon. Then I have 2 copper here, so I'll get 2 copper. So the copper, 2 of copper, 2 of copper, 1 of carbon, 1 of carbon, 2 of oxygen, 2 of oxygen, because there's no oxygen there. All right. Moving on to the next one. What do we have here? So it looks like if it is 1 1 1 1, then you only have 2 oxygen on the left, but you have 2 plus 1, which is 3 oxygen on the right. So that doesn't make sense. So we got to try and make sense of it. If I put 2 here, then I get 2 oxygen. If I put 1 there, then I get 1 times 2, which is 2 oxygen. 2 times 1, which is 2 oxygen. Altogether 4 oxygen on the right. If I put 2 there, then what about my lead? My lead is the Pb. So 2 of the lead, if I put 2 there. So the Pb is balanced, the oxygen is balanced, but the sulfur is not balanced. Look, there's 2 sulfur and there's only 1 sulfur. So that is not good at all. So perhaps I can change that. So what we'll do here is to change out the 2. We put the 2 in front there. And in doing so, now we have 2 sulfur and 2 sulfur which are balanced. But the oxygen, I have increased the number of oxygen because now I have 2 of the SO2 molecules. So recount the oxygen. So 2 times 2 is 4 oxygen. These are 2 times 1, which is 2 oxygen. So altogether on the right hand side, there is 2 oxygen plus 4 oxygen. There's 6 oxygen. This is 2 times 2 from before. So that is no longer correct. It should be 3 times 2, which is 6 oxygen. As you could see, the simplest whole number ratio, 2 is to 3 is to 2 is to 2, and that equation is balanced now. Moving on to the next one. So we can see the nitrate fragment. There is 2 of them in one formula unit. So if I say I started with 1 of these, then I will have 1 of zinc nitrate. That means there's 1 zinc 2 plus and 2 of the NO3 minus, which automatically means I should have 2 of the NO3 minus, because the NO3 minus is one whole unit. So you balance it by balancing the one whole unit. In doing so, you have 2 Ag, which is 2 silver. So they'll give me 2 Ag. And the zinc is balanced out from the thing on the right hand side. There's only 1 of the zinc. So there's only 1 of the zinc, and that equation is balanced. All right. Now part B, we need to write balance equations as well as include stat symbols. Usually I don't have to worry about stat symbols unless, well, at least not at this stage when you're just learning how to balance equation, but I'll probably put them in anyway. So aluminium is a solid. Aluminium plus steam is H2O gas. I'm trying to leave space so that I can balance equation easily. Aluminium oxide is Al3 plus O2 minus. So you can think about you need 2 of these to balance out 3 of these. So it's Al2O3. Hydrogen gas, remember, does not exist as atoms, they exist as molecule. Now to balance this equation, if I start off with 2 because I have 2 aluminium there, then the hydrogen is 2 but the oxygen is just 1. I have 3 oxygen here, so that doesn't make sense at all. So perhaps I shouldn't start off with that. I can start off with this 2 aluminium and 3 oxygen. So I can start off with 3 oxygen because 1 H2O has 1 oxygen, so 3 H2O has 3 oxygen. 3 times 1 give you 3 oxygen on the right hand side. Hydrogen, there's 3 times 2 which is 6. Here I only have 2 hydrogen, so I need 3 of the molecule. So it's H2 and then another H2 and another H2. Altogether I have 6 hydrogen atoms. And of course I have 2 aluminium now, then I have 2 aluminium like this. Okay, aluminium oxide is a solid. It's a giant ionic structure. Metal ion, non-metal ion, very high melting and boiling point, a solid at room temperature and pressure. Hydrogen, simple covalent molecule, simple molecular structure, is a gas at room temperature and pressure. Okay, the next one is this thing called solution. Solution is something which is in water, so this thing dissolved in water give you aqueous solution. So calcium plus water, which is H2O, then I'll get, this is calcium 2 plus OH minus, so you will need 2 of the OH minus. You need 2 of the OH minus because if you think about the crisscross method, it's the same thing as the idea of LCM, lowest common multiple. You bring down the value, you don't bring down the charges. You never cross multiply the ions. The ions are where they are. The charges belong to the ions, they are where they are. What you cross multiply down is the value of the charge, which is number. Okay, so what does this mean? This means 1 of the calcium 2 plus. And what does 2 mean? It means you have OH minus and you have OH minus, so therefore you have calcium with 2 OH minus. So it's calcium 2 plus with 2 OH minus, so it's calcium OH twice. The most common mistake that a lot of students will make is they just write like this, which is wrong, because that would mean 1 oxygen and 2 hydrogen, whereas it should be 2 oxygen and 2 hydrogen, 2 oxygen, 2 hydrogen, minus 1, balance out the plus 2. Alright, be very careful when you balance chemical equation. So that is calcium hydroxide and it's aqueous solution. And then I'll add H2, which is a gas. So I'll remove that. So let's try and balance the equation. Should put in the solid and the liquid there. What do I have here? I have 2 oxygen and 2 hydrogen plus 2 hydrogen is 4 hydrogen. So I need 2 water. So 4 hydrogen, 2 times 2 hydrogen. There's 1 oxygen, but I have 2 of the molecule. So 2 times 1 is 2 oxygen. 2 times 1 inside, so this whole thing means the whole OH, there are 2 of them, just like this. Okay, so if you can't see this, you should be able to see this. From this you should be able to get this back and forth. That is year 9 chemistry for you, okay, that you will use in year 10, year 11 and many years if you want to stay in doing chemistry. Okay, magnesium as a solid, sulfuric acid is H2SO4, is in water, so it's aqueous solution. Magnesium sulfate is a Mg2 plus SO4 2 minus. So the 2 plus and the 2 minus cancel each other out in a 1:1 ratio. So it's just MgSO4 plus H2. Should put in the stat symbols. By the way, magnesium sulfate is what you could consider soluble. You will learn more about solubility of salt eventually at a later topic. But at this, in this particular regard, you can trust me when I say it's aqueous. Not very soluble, but it is soluble to some extent. Okay. Balancing the equation, sulfate come from the sulfuric acid. 1 sulfate unit come from 1 sulfate unit. Mg, one of them. H2 give you the H2 gas. This is a metal plus acid, give you metal salt and hydrogen gas. This is a metal plus water, giving you metal hydroxide and a hydrogen gas. Alright. Now zinc oxide, what do I have here? Zinc 2 plus and O2 minus. So I have ZnO. This is a giant ionic structure, so it's a high melting and boiling point. And carbon could be graphite, could be diamond. I imagine it will be graphite most likely because graphite is a lot cheaper than diamond for these random reactions. It is not simple molecular. You do not have a carbon 2 at the bottom or 3 or 4, whatever. It's a giant molecular structure where you don't have a single molecule, therefore you do not have a number to indicate how many in one single molecule. Zinc is a metal, so it's a solid. In fact, there's only 1 liquid metal in the whole periodic table, and there's mercury. The other are all solid. Carbon dioxide, 1 carbon 2 oxygen, is a gas that you are breathing out. It's called respiration. Now you got to balance the equation. 1 zinc, 2 oxygen here. So if you have 2 oxygen there, how do I balance it? Then I need 2 oxygen by putting 2 Zn. Oh, there's 2 oxygen, but there will be 2 zinc. So I'll get 2 of the zinc and 1 of the carbon, and that equation is balanced now. All right. Aluminium plus oxygen. So remember I talked earlier about oxygen does not exist as single atoms. So when you see oxygen, the aluminium is a solid, the oxygen exists as O2 gas, and then they'll give you aluminium oxide, Al3 plus, O2 minus. So Al2O3 is a case study. Back then when I did the lesson tutorial on aluminium oxide and the dot and cross, you can go back to that exercise or that tutorial and look it up for yourself, okay? And it's a giant ionic structure, so you need to balance the equation. This is 2, this is 3. If I put 1 here, then there will be 3 oxygen, and I want 3 oxygen, which will be quite hard. It's not impossible to balance with fractions, okay? So these are just symbolic representation. You can use fraction if you want to, but I try to make it simpler for you by using whole number. So what I'll do is I put a 2 in front. 2 times 3 is the same as 3 times 2. That's how I balance the oxygen. Because 2 times 3 is 6 oxygen. This is O2, I cannot change it to O3. So O2, 2 times 3 give me 6 oxygen. And in doing so, I have 2 of these. So aluminium, there are 2 in 1 unit, but I have 2 of them. So 2 times 2 is 4. So it's 4 aluminium there. Okay. Iron 3 oxide, iron 3 plus, O2 minus. This is what you call the oxidation state, something that will make sense when I cover a topic called redox changes in a few months from now, or perhaps next year. So this is a plus 3 and a minus 2. It's just the Al3 plus O2 minus. I bring down how many of these do I need. So I will have 2 of the iron 3 plus, and I'll have 3 of that. So what I'll have is iron 2, 3 oxygen. Okay, sorry, not iron 2, iron 3 plus, but it's iron 3 oxide, but I need 2 of the iron 3 plus and 3 of the O2 minus. And there's a giant ionic structure as well, so it's a solid. You add carbon monoxide, it's a poisonous gas, it can kill you. Monoxide, so it's just 1 oxygen. CO2 dioxide, so it's just 2 oxygen. So now I need to balance the equation. This is actually a case study you will learn as part of chemistry of iron when you come to the topic called metals. Not this year, not next year. Oh, actually perhaps next year. Let's try and balancing these equations. So if I put 2 there, then I'll have 4 oxygen. Then if I put 2 here, I'll always run out of problem because I'll have lesser carbon. I'll show you what I mean. If I put 2 here, which is alright, and then I'll have 3 plus 1, which is 4 oxygen. So 2 times 2 is 4 oxygen. I have 2 carbon, but if I only have 1 carbon there, then I need 2, and then that means I'll have more oxygen again, and I run into problem again and again. All right. So is it 2? Let me see. What happens if I have 2 there? So this thing you really need to play around. If you have 2 carbon, then it's 2 carbon. Then there's 4 oxygen, 2 oxygen plus 3, that's already 5. So that doesn't make sense at all. How about 3? If it is 3 carbon there, it must be 3. Then there's 6 oxygen, then there's 3 oxygen plus 3 oxygen. That means it's 6 oxygen now. So 3 oxygen there, 3 times 1 is 3 oxygen there, 3 plus 3 oxygen give you 6 oxygen, 3 times 2, 3 carbon, 2 iron, and no number in front means it's 1. It's already balanced just like that. Okay, this will become a really important case study, an equation that you have to know from scratch. Very, very important. The same goes for these as well. Yeah. Okay. Now practice with equations. So what do we need to do here? We need to try write the equations for this. I think I'll probably just write here because the questions are here. 1a, what do we have? Oops, no, I don't want that. So 1a, what do we have? We have hydrogen as a gas, which is H2. Copper oxide will refer to copper 2 oxide, by the way. My bad. Copper 2 plus, O2 minus. They will give you copper as a metal, and they will give you water. So the H2 take away the oxygen and kick out the copper as a metal, and H2O, that thing is just balanced straight away. All right, so nice and easy to start with. Carbon as an element exists just as C. Okay, you don't write any number at the bottom because it is not simple molecular. CO2, carbon dioxide, give you CO, which is carbon monoxide. This equation is not balanced because one oxygen here, two oxygen on the left, and there are two carbon, there's only one carbon there. So what I do is I put a 2 in front, one carbon, two carbon, two carbon, two oxygen. So two oxygen, the equation is balanced now. C, carbon plus oxygen, giving you CO2. Oh, that is the easiest one to balance. One carbon, two oxygen, all right? And then D, magnesium plus sulfuric acid, giving you magnesium sulfate, Mg2 plus SO4 2 minus, magnesium sulfate, and then H2 gas, all right? So MgSO4, acid plus metal, metal salt plus hydrogen gas. And then what happened with E? With E, you have copper 2 chloride. So you have Cu2 plus and Cl minus, plus 2 minus 1. So you bring down the value. So what this means is you have 2 Cu2 plus and you have Cl minus. So you have CuCl2. So that means 2 of the Cl minus, 1 of the Cu2 plus. The formula is CuCl2. Let's try to balance the equation. Copper, chlorine is group 17 that exists as a diatomic molecule like this. Chlorine, bromine, iodine, fluorine, they are all F2, Br2, Cl2, I2. Okay. Copper 2 chloride, the formula is CuCl2. So the copper, one copper give you one copper, 2 Cl give you here 2 Cl. So this equation is also balanced just like that. Alright, so I think what I'll do now is I'll try and write the answer for question 2 at the bottom here. So we need to try and balance the equation here. Calcium plus water, giving you calcium hydroxide plus hydrogen. I know that they give you hydrogen first, but I'll write the calcium hydroxide first, which is okay. Metal plus water give you metal hydroxide and hydrogen gas. The metal is from group 2, so it's calcium 2 plus OH minus hydroxide plus 2 minus 1. So that is the charges. And when we do cross multiply, what we're doing is we are doing the lowest common multiple, by the way, where we just take the value, so it's just 1, and we just take the value, it's just 2. So what does that mean? 1 of the calcium 2 plus, 2 of the OH minus, just like that. 1, 2, only 1. Now, when you put them together, what does the formula look like? It means 1 calcium 2 plus, bracket OH twice, because there's 2 oxygen, 1 and 2, and there's 2 hydrogen, 1 and 2. Okay? The most common mistake, as I said before, is things like that, and that is a big mistake because people don't understand that it's the charges that get balanced out and how many of the hydroxide would you need and what is the meaning of this number at the bottom there. Okay, now let's try and balance that equation. So I have 1 calcium and 1 calcium. I have 2 oxygen because 1 times 2, there's only 1 oxygen there, so put a 2 in front. Now you have 4 hydrogen, so there's 2 hydrogen plus 2 hydrogen, there's 4 hydrogen there. Okay, now to part B, I have copper plus oxygen. Oxygen exists as diatomic O2 molecule. Give you copper 2 oxide, Cu2 plus O2 minus, therefore 1:1 ratio. This is 2 oxygen, so I'll put a 2 in front, and now I have 2 copper, so I need a 2 in front of the copper as well. Okay, 2C, sodium plus oxygen, which exists as O2, sodium oxide. Sodium is from group 1, so Na plus. Oxygen is from group 6, so it's O2 minus. Hope you can see it's Na2O, because you need 2 of these to balance out the -2 charge. You can do the cross multiply, or you can think about the LCM of 1 and 2, which is just 2. Okay, now there's 2 oxygen, there's 1 oxygen, so what I'll do is I'll put a 2 in front to get the oxygen balance. So now it's 1 times 2, which is 2 oxygen, and there are 4 sodium, so what I'll do is I'll put a 4 in front there, and that equation is balanced now. Part D, I have iron, hydrochloric acid is HCl, so what I'll do is, no, actually that should be alright. Iron 2 chloride, So it's iron 2 plus Cl minus, iron 2 plus Cl minus. All right, so I hope you can see there's iron 2 plus Cl minus. You should be able to do this on your own. Eventually you can kind of do the cross multiply thing in your head, or you can think about the LCM, or you can just look at the charges, think about how many of each you need to balance out. So 1 of the iron 2 plus, you need 2 of the Cl minus, 2 of the Cl minus, so meaning I write 2 times. So the formula is FeCl2. This is called iron 2 chloride. Alright, you gotta be very good at it eventually, otherwise you will struggle with balancing equation as well as all the things that come afterward. This equation is not balanced. I've got 2 chlorine, I got 2 hydrogen. Very easily I could just put a 2 in front there. And last but not least, I have iron plus chlorine giving me iron 3 chloride. Iron 3 chloride. So iron plus chlorine giving me iron 3 chloride. Iron 3 chloride is Fe3 plus, so I need 3 of the Cl minus. You can try and do this cross multiply method. You can try to do the LCM method of 3 plus and minus 1. Well, 3 and 1, the LCM is 3, so I need 3 of the minus 1 to balance out 1 of the plus 3. Of course, this equation is not balanced. I've got 3 chlorine here, I've got 2 chlorine here. The easiest thing really is to put a 2 in front, then I'll get 2 iron, then I'll get 3 chlorine molecule. 3 times 2 give me 6, 2 times 3 give me 6. Alright, so let's balance it. And now in terms of balancing this last bit of equations, let me just try and duplicate this page, copy, and I want to paste it. So I just want to work with a clear page again, but that doesn't remove my answer for the previous bit, but at least now I can just balance this equation. Alright, so for the first one, Na2O is called sodium oxide, Na plus O2 minus. You need 2 of the Na plus to balance the O2 minus. This is a simple molecule, there are no ions, H2O liquid, and this is Na plus OH minus. It's called sodium hydroxide. You need to balance the equation. There's 2 sodium, read from left to right, 2 sodium, 1 oxygen. So I need 2 sodium. And then there's 2 oxygen now, 2 times 1 oxygen, 1 oxygen, 2 oxygen, 1 times 2, 2 hydrogen, 2 hydrogen. So this equation is balanced now. Next one, you see you have 3 oxygen here, and no oxygen and 2 oxygen. So the best thing you can do is put a 3 and a 2, because then 2 times 3 is 6 oxygen, 3 times 2 is 6 oxygen. Now I have 2 KCl, so I need 2 of the K and 2 of the Cl to balance my equation. The next one, H2O2. So the oxygen is definitely not balanced. You only got 2 oxygen here. You got 2 plus 1, which is 3 oxygen. So what I can do, if I don't have 1, I can put a 2 there. And if I have 2 H2O2, I hope you can see that will give me 2 H2O. And that will be 4 oxygen. 2 times 2 is 4 oxygen. 2 times 1 is 2 oxygen. 1 times 2 is 2 oxygen. This equation is balanced there. Next one, this is a iron, this is a mixture, I hope you remember, FeO, Fe2O3, so it's a 1-to-1 mixture, therefore what you get is 1 plus 2 is 3, 1 plus 3 oxygen is 4, so this is iron 2 oxide, this is iron 3 oxide, okay, the oxide is both O2 minus. Now to balance the equation, I've got 3 ions, so 3 iron, I have got 4 oxygen, this is O2, so I need 2 O2 to balance the equation. Mg plus N2, so this is 1 of it and 3 of the magnesium, so 3 of the magnesium and 1 of the N2, this gives me 2 nitrogen. Alright, so that thing is balanced. NH3 plus O2, okay, so you got 3 hydrogen, you got 2 hydrogen, there's no other hydrogen, so the best thing you can do is make this 2 and make this 3, because 6 is our common factor. 2 times 3 is 6 hydrogen, 3 times 2 is 6 hydrogen. What do we have now? The N is balanced, the H is balanced, now the oxygen. The oxygen, there are 3 of them, but this is an oxygen molecule, so 3 times something is equal to, 3, I need 3 on the right hand side. Sorry, I have 3 oxygen on the right hand side. I need what number in front? multiply by 2 because in one molecule there are 2 oxygen atoms. So x is the number in front, is 3 over 2. So what I've done for the first time is to use fraction. This is 3 over 2 because 3 over 2 times 2. Where does the 2 come from? Because it's a molecule. So altogether, you are totaling up. You're trying to find the sum or the total of the atoms. Oxygen atoms is 3 oxygen atoms. In terms of molecule, you have 3 over 2 molecules, which again doesn't make sense, but this is a balanced equation. This is a symbolic representation. It is not what really happened in reality, but the number is simply a representation of it. If you want, once you get the smallest number, you can multiply the whole thing by 2, because to get rid of the thing at the bottom, 3 over 2 times 2 will give you, cancel out the thing at the bottom. You just get 3. But this is 2 will become 4, this is 1 will become 2, this is 3 will become 6. So what you can do also is multiply that thing I have on the left, multiply by 2. Okay, and you will see what I'm saying. The equation is still balanced. It's just in a whole number multiple. It's the simplest whole number ratio. This is a fraction ratio. Both of them are equally correct. Now iron plus H2 will give you this Fe3O4. So there's 3Fe because of 3Fe. And there's a H2 and H2. So there's 4 oxygen. So I have only 1 oxygen there. So I should have 4 oxygen. Now I have 8 hydrogen. I only have 2 hydrogen. So I need 4 H2 to give me 4 times 2, which is 8 hydrogen. What do I need next? H2S plus O2. So I hope you can see the oxygen does not get balanced out. There's only 2 here, and there's 1 and there's 2, which is 3 oxygen. But the H is balanced out, 2 of them. The S is balanced out. I have 3 oxygen atoms on the right hand side. 2 plus 1 is 3. I have a molecule. I need to make it 3. How do I get 3 here? When I have a molecule, 3 over 2 times 2 give me 3 oxygen atom. So I'm going to apply the same trick, which is to use fraction, and that will balance the equation. If you don't like, multiply the whole thing by 2, and you will get rid of the fraction. When I multiply the whole thing by 2, I mean the whole thing. This is your maths, so be very careful. 1 times 2 become 2. 3 over 2 times 2 become 3. And then 1 times 2 become 2. And 1 times 2 become 2. And that's how this is also correct. Now for the last one, H2S, the S and the S, but I have 2 sulfur, I only have 1 sulfur here. I have 2 oxygen, I only have 1 oxygen here. I think the best thing to do is balance the oxygen first. I'll get 2 H2O, because then I'll get 2 oxygen. 2 times 1 is 2 oxygen. On the right is 2 oxygen, on the left is 2 oxygen. Because now I have 4 hydrogen, I only have 2 hydrogen here, because no hydrogen here. I'll put a 2 in front. 2 times 2 is 4 hydrogen. That balances the hydrogen. But now I have 2 sulfur plus 1 sulfur. I have 3 sulfur. So I get 3 sulfur. And that's it for this tutorial. So I mean, it's a bunch of work on balancing equations, recognizing your formulas, being able to write formulas from names, and of course being able to identify the names from the formula itself. All this should be done in your head by this level, and you need a lot more practice. You can go back to exercise, cover them up, and try and do them again. Especially with regards to balancing equation, you must know your word equations. There are a couple of standard reactions like metal plus water, metal plus acid, acid plus base, and other stuff. Okay, and once you know your word equation, you must know your table of ions. These are not provided. You're expected to be able to construct any formula given them, and you're expected to name from any formula at all. Okay, so that's it for this tutorial. Yeah, I'll see you in the next tutorial. Thank you for watching.